this. Now, let's now define radian because that's the key. That's the key. So I'm going to show another screen now. Let's now define a radian. So actually the title of this should be Radian measure. Okay, so now on this radian measure, we start by drawing a circle. Then we have a center of a circle, and then we draw a radius from the center. And somebody can move from this point and then keep going around the circle and then stop at this point. And then if you draw another radius from the point of stopping, this also becomes another radius. And of course, you can see that there is an angle that is measured. And this angle, you can call it theta. Theta is the usual Greek alphabet that is used to represent angle. Now, if this person that started here, if this person moved around completely and completed the circle, that person would have covered a circumference of the entire circle. So which is C equal to 2 pi multiplied by radius. Okay, now the same person who started here, if he goes round and come back to where they started, it means they have covered 360 degrees. 360 degrees. If you are measuring the angle. Now, how do you get this 360 degrees? Okay, see how. Let me draw a little more circle here. And let me divide this circle into 4 equal parts. So now in these 4 equal parts, if you pick your protractor now and measure each of these angles, each of them is going to give you 90 degrees. So this is going to be 90, 90, 90, and 90. So now when you add up these 390 degrees, that's how the 360 degree came about. Okay, so now we are talking about 360 degrees is also equivalent to what? 2 pi radius. 2 pi radius. 2 pi radius. So now if and only if this radius is unit, is 1. If the radius is 1, then this angular measure will now turn to radian. If the radius is 1, then this measurement now turns to what? Radian. So if radius is equal to 1, which is the same unit circle but there, that's the unit circle there, then 360 degrees turns to 2 pi radian. As a matter of fact, radian is defined if the length of an arc is equal to the radius of the arc. So let me repeat. Radian is defined when length of arc is equal to the radius of the arc. All right. So for example, if the length of arc is 5 and the radius is 5, that's radian right there. Okay, so now let's do a little more analysis. So we have established that this particular degree. Now, how about if you look at the left and the right side, you will see that the left side could be written as 180 degree multiplied by 2, and that's also equal to 2 multiplied by 5 radian. So now if you divide 2 on both sides, 2 here, 2 here, so these 2 crosses out. So you are getting that 180 degree is equal to 5 radian. So this is a very important, both this one, actually both the first one, which is this, and the second one, which is this, are very important. So it is the conversion rate between degree and radian. So this is like saying 12 inches is equal to 1 feet. Okay? So 180 degrees is equal to 5 radian. Let me box it. So you can call it conversion rate. Conversion, correct any wrong spelling, rate.